Okay, so that's at both t equals 2 seconds and t equals 6 seconds. Average rate of change over the 3-second pause. Again, delta d over delta t. Well, the change in distance at that phase, well, the change in distance from time equals 8 seconds to time equals 11 seconds, that change from the distance from the CBR is actually going to be 0. And the change in time is going to be 3 seconds. Therefore, 0 meters per second. That's just a different way of writing meters per second, just to keep it in one line. What do you have when you have a negative exponent? Yes, you take the reciprocal, which would then be the same as 0 meters per second. Okay, so now let's take a look at this next part here. We want to now calculate the average rates of change over the last 4 seconds. And so that is delta d over delta t again. And so we know that the change in distance is going to be 4 meters. Change of time is going to be 4 seconds, as outlined in the description. And you do a little nifty dividing in your head, hopefully, and we get 1 meter per second. So then, we want to find the instantaneous rate of change at t equals 12 seconds, t equals 14 seconds. Well, those two speeds are going to be the same because this is constant rate all the way along there. So at t equals 12 seconds and t equals 14 seconds, because that's constant rate, the instantaneous rate of change is going to be the same as the average rate of change. So the instantaneous rate of change is going to equal the average rate of change equals 1 meter per second at both t equals 12 seconds and t equals 14 seconds. And now what we want to do is draw a speed versus time graph for the student's CBR walk. Okay, again, speed in meters per second and time in seconds. And here we know that for the first 8 seconds the speed is 1 meter per second from what we saw on the other page. So for the first 8 seconds it's going to be 1 meter per second. Then for the next 3 seconds it's going to be 0, and I'll just draw this a tiny bit above the axis so we can actually see it. And then for the next 4 seconds it'll again be 1 meter per second for those 4 seconds. Okay, now this is speed versus time and not velocity versus time. If it were velocity versus time, then you'd have to take into account direction. But in this case, we don't have to take into account direction because it's just speed. Okay? So that is the lesson for 2.4. There's your work. Please work on the first few questions there at home and then come in to work on the rest of them. And there are the review questions, as this unit is fairly short and will be coming up to a test fairly soon. See you in class.